Thanks, Aparna. Sorry, my voice is weird this morning. So with all that said, let's see if I can figure out how to present this properly. Is that showing up for everybody? Oh, let me send you all the link just in case you want to self-pace a little bit too. Or actually, Rob, would you be able to send out the link? I can't get to chat anymore.
Give me a sec and I will go grab it.
Thanks. Cool. So today's presentation is going to be a little bit informal in the sense that if you get lost or stuck somewhere, I would hope that you will raise your hand and pause us and try to get a little bit more clarification. If you're totally lost, if you're, I don't know, there's going to be some moments that maybe just don't make sense for everybody, and that might also be fine. So take what you need out of it. I'm realizing just now that I'm not going to do a great job of seeing hands while also presenting my screen. Is there somebody who would be up for taking on that role? Maintaining stack. Thanks, Rob.
Yeah, I'll do it.
Cool. So we're here to talk about the decentralized web, what it is. Definitely have angled this talk from an archival space perspective, which is interesting given that my background is not there. What that mostly means here is that we are talking about archival space as opposed to talking about like social space, et cetera, because the decentralized internet is pretty big. So sort of the impetus for looking into decentralization for a lot of folks. This is from a blog by Andre Staltz, who's involved with some of this, building some of this technology. Looked up and figured out that 70% of internet traffic is directly controlled by Google and Facebook. So that is going through google.com or facebook.com or owned domains of theirs, which is kind of crazy because they haven't been historically very effective at treating our information like it is a thing to be respected, and like the users are also to be respected and treated as, you know, a global community. The logo I put on this slide, by the way, is the Cambridge Analytica logo, but there are other instances. So EDGI was formed out of a concern that the government may not be super trustworthy in saving and representing data to, saving and making accessible the public's data, especially around the environmental space. So when we look at the internet and the way that data is currently saved, so that 70% number was about traffic, and I was trying to find, but was not able to find, I believe there's a similar metric around like how much of the internet is owned on servers held by Facebook, Google, and Amazon. Definitely also over half, startlingly high. I can't remember exactly what the stat is, so I can't quote it to you. But if we don't want them holding our data, the question then is who should hold the data? And from the EDGI perspective, who should hold the environmental data that belong to the public? And especially, how can that data be collected, held, and distributed in a just manner? And that ties into the work that we've been doing around this concept of environmental data justice, where we want environmental justice pulls the concept that the most affected folks by environmental or by climate change and environmental actions tend to be the same folks who don't have a lot of voice. And then data justice asks the questions of who's holding data, why they're collecting it, and who's benefiting off of it. So environmental data justice kind of combines those two fields. So the decentralized web is a way of positing that maybe the public should hold the data that relates to them, that represents them, and that they need in order to be effective. So Edgy originally started by doing data archiving. And through the web monitoring effort especially, and you guys on this call are more expert on this than me, but there's a concern that if a link is broken, maybe you no longer have access to the data that's really important. If the link breaks, you can't find it. But even if something is downloaded, you can't necessarily prove in a way that's useful, say in court or even in a scientific thesis, if your data is not directly matchable to something that is held in an authoritative place, like a .gov address, you might not be able to use that data set for making the point you need to make. And in order to work with data, scientists will typically download the data sets. But even though there might be lots of copies of this data set, there's not currently a good system for sharing that data, like if one gets lost, or if the centralized version gets lost. Something we've been talking about in the Data Together group recently, and in an ongoing way, is this concept that data requires continuous stewardship. And I was recently looking at a paper that's in progress within the Earth Science Information Partners that Mark's coming from, around data risk matrix. And this paper currently opens with the statement that any data that is not like actively maintained to not die, to not be lost, should be considered not safe. Especially digital data. In our early discussion here, we talked about operating systems and the different programs that, like Sarah was talking about, the games that you can't find anymore. And it's kind of funny because those are not obscure games, but just because they exist in a digital space and can be copied freely, doesn't mean that they're going to run on future computers without someone like bringing them forward. So that's a part of the problem, and the other part is just this idea that like you have to pay to have a server, like it costs money to have a server holding data and continuously having uptime such that people on the internet can receive it. So we have to ask the question of who's able to hold and distribute data and who is not, and what data is well kept and for whom, and who makes those decisions. So starting to move into the more technical sphere of this is a quote that is about what data stewardship is. And so it's saying, applied to information, stewardship focuses on assuring accuracy, validity, security, management, and preservation of information holdings. And from this list, there are two that I called out that strike me as particularly well thought about within the decentralized web space. And one of them is this concept of validity that I brought up already, which it sounds like Mark is going to be excited to hear about, with how you verify data that exists on the DWeb as being the data that it purports to be. And then the second part, preservation, is was also already alluded to, of we have many copies of the thing, and having more copies of a thing makes it safer, but you then also need to have a way of sharing that data among people. So looking a little bit more into this concept of lots of copies keeps stuff safe. It means a couple different things. So this is a concept from the archival space. It's also the name of a software that helps facilitate the sort of distribution of things between several libraries and institutions. So it is itself fulfilling its principle. But the basic concept is that if you are seeing something on the internet, it has been downloaded, however temporarily, to the computer that you're using to view it. So in principle, using the data could become a form of stewardship of the data if you had a mechanism to save it and share it back out. If you ever used any of the logos currently on screen, we've got LimeWire, the Pirate Bay, MicroTorrent, and BitTorrent here. I'm actually curious, how familiar are these by show of hands to folks on this call? Have any of you ever used them? Okay, we got a couple hands.
How do I show a hand?
Oh, with your video. Good question.
Oh, sorry. Yeah, I'm fine. But yes, I'm familiar with them.
Cool. So, so these are kind of precursors to the decentralized web idea. And it's kind of neat because it's like, there's some stuff that a lot of different people care about and have copies of. And if you want a copy of it, you could ask your peers for the different parts of it and download it to your computer from them directly, rather than from some centralized source. These are not traditionally used for scientific purposes, but there's no reason the principles don't hold true. One of the things that you might worry about when you're using something called, for instance, the Pirate Bay is, am I really getting the content that I'm asking for? And maybe, is this from someone with a good reputation? These are problems that the decentralized web doesn't completely address, but there are mechanisms that kind of help with that. So in that space of provable validity, we're asking the question of, how do I know, like if I'm looking for a specific NASA data set, and I'm asking for it from a web of peers, how can I be sure that it's actually the NASA data set and not some fake garbage from someone random on the internet? And there's two different ways that we try to look at this. One is this concept of digital fingerprinting that asks, is this the right content? So this is for content that is static and doesn't update at all. And what we're trying to figure out is whether the thing that you're downloading is an exact match of another thing that you know to be correct. So maybe you've received from an authority some identifying information that would let you check the copy that you're getting against the copy that you know to be the one you're looking for. The other thing is the digital signatures, which is more the question of like, can I trust that this came from who it says it came from? So maybe in the farther future where there is no nasa.gov because everything's decentralized, maybe there's still a website that is effectively nasa.gov and you need to know for sure that only NASA can post to this page. And that's what digital signatures do. And we'll go into the mechanisms a little bit more, but basically, it can only be, with a digital signature, you can be certain that only the person who is supposed to put the thing on there could put the thing on there. Which is not to say that any of this is unhackable, but it would be hard. So in the realm of content-based addressing, bear with me here, there's code on this slide. So this is honestly one of my favorite concepts within the distributed web space. The address of the content is built from the content itself. So if you were to go to, maybe I'll put this in this order. If you were to go and look for a website that I put up and look for a specific piece of content, you would go to, can you see my cursor? Cool. So you'd go to HTTPS, which is basically explaining the protocol that you're using, which is kind of like saying the grammar. What should I expect after this protocol indicator? And then secondly, I'm going to ask a specific authority, which is, in this case, the getbooks.io domain with the subdomain freehole. And then I'm going to ask for a specific location at that authority's server. So that's standard for current internet. And then in a content address space, what you'd do instead is you'd say, I still need to put this protocol first and say what kind of grammar I'm going to use for the next part. But then after that, I'm going to ask for this long alphanumeric string, which signifies the thing that I'm looking for. And what's really important to note about this is that I'm not asking for a who, and I'm not asking for a place at all. I'm only asking for the thing. And coming back to this slide, that address is generated based on the contents of the thing that I'm looking for. So it takes the entirety of the content and it runs it through an algorithm that scrambles it up and creates this fairly high probability of being very unique key that signifies it. And if you look at the code on this slide, so what we're doing is we're looking at a text file that says hello world. And then if we add it to IPFS, it runs it through that scrambling algorithm and gets back what IPFS calls a CID, a content identifier. And you can see that it's this very long string. But so this is the exact same file, hello.txt. What I've done is I have gone into that file and I've modified it by adding a comma. And if I take that exact same file and I save it again to IPFS, you'll notice that it sends me back another string that's super long, but is completely different, other than the Q at the front. And that's just a way of showing you that if I modified it at all, I would get back a different string. Why that's important for our purposes is if you had so earlier this year we had a problem that the Sierra Club came to us with and said, hey, there's a fire going on in Texas, and we're worried that there is a probability that the people who are somewhat legally responsible for this fire are also the same people who are producing and distributing the data about the benzene released by it. Right now, that data is available online. Can you download it such that we can use it in a legal case maybe 6 years in the future? And we need to know, basically, that the file that we save on a certain day, as close as possible to that time, 6 years in the future, we need to know that it is the same data unmodified. We need to be able to prove that validity in order to have it be useful in court. And we don't know that they might go in and change anything, but there is like a danger, there's an incentive structure set up such that like if they wanted to get away with legal culpability through some kind of malicious tampering with the data, we would be able to tell whether the data that appeared to be in the same place was in fact the same. Is that making sense? And that's like, even if they changed one decimal place, it would be a totally different identifier. So if you ask for the content rather than the address, you know exactly what you're getting back, assuming you know exactly what the hash that you have represents.
So we've got a question from Sarah, so she was curious if it's feasible to reverse engineer the content if you know the algorithm and hash. And the answer is, for the types of hashes we use for this kind of system, no. And that's intentional. So in the idea of what hashes are is like a big space of different kinds of algorithms and tools. And then there's a smaller space that is digital fingerprinting, which is sort of, you're trying to get more of a guarantee of uniqueness. Two similar pieces of content won't get the same fingerprint. And then in the idea of what's called cryptographic hashing, which is a subset of fingerprinting, one of the important and principal ideas in cryptographic hashing is that you should not be able to go from the hash or from the fingerprint back to the content. So once you've crunched the content down into this fingerprint, you can't really figure out what the original content was if all that you have is a fingerprint. But the fingerprint is pretty unique to that content. So if you've got the fingerprint, you can go find the content based on the fingerprint, but you can't reverse engineer it to figure out what the content was. And there are many, many different cryptographic hashing algorithms. And occasionally as we go through time, they get proven to have problems. And so people invent new ones that are more reliable. And many of these distributed web systems that rely on these algorithms have built-in ways of exchanging algorithms and refreshing the content you have within your one to try and get around that issue. But yeah, many of them are standardized by NIST, National Institute of Science and Technology, and other large international organizations related to that kind of stuff.
Thanks. So this slide's just kind of recapping what we know about content addressing, which is that it solves part of the problem of knowing that you get what you ask for, but it does not solve the whole problem of the decentralized internet by itself. We would still need to know where that hash came from, that fingerprint. It only works if you can verify the fingerprint against something. There's also this challenge that this only works for static content. Like, that's what's good about it, but it's also what's challenging about it. If you know that it can't change, what if you have a data set that actually updates over time and you need to get those? Now you have a different problem. And then finally, as is true of all things on any internet, you do need the data to be kept somewhere. And if it's not to be kept at somewhere held by a central authority like .gov, which has funding to have servers to have uptime, you need there to be another way for the uptime to exist, for the thing to be held online when a user is going to want it.
I have a question. This is Mark. Is there a way to sort of gracefully retire or redirect one of these identifiers, the fingerprint? So say you have data that you've deleted, but you still want to know people that there's an updated version, or this is what happened to it, because that's basic stewardship practice. Is data does get deleted, sometimes intentionally, but then you try and at least say what happened to it and what replaced it, if anything. So is there a way to address that? So I have this fingerprint that was minted 5 years ago, but that data is deleted. What does it resolve to now? Just nothing? Is there a way to address that?
Rob, maybe you can help me out here with what IPFS does for a mutable file system, because I remember that they have a solution. But essentially, my understanding is that either the thing exists or it simply does not resolve. And the only way that you might have your thing point to a future version would be that if you thought about it ahead of time and said, this is where you should look for the next thing as part of the original content. Do I have that right?
So this is a part where I guess I would say it's a little bit complicated because it depends on which particular distributed web system you're using. So one of the things I think Kelsey is going to get to in a little bit is talking about how there's a full universe of different tools and solutions here. And they all have very different approaches to all the pieces of these problems. The core thing that's in common with them is this idea that you have many copies of everything all over the place. You can get it from your peers and from other people near you rather than from some centralized source that might be untrustable or might be faulty in some way. And so they all have slightly different answers to this question. But at large, there's sort of two questions in there, which is what happens in the case where data is deleted? And then how do I redirect from an old or deleted version of something to something new? And for that first question, the fairly universal answer that most of these systems have is that it's hard for data to get deleted. So the idea is that you've got lots of people serving and saving this data all over the place. And so it's unlikely that deletion in any way that's not intentional and largely agreed on by everybody on the internet will ever actually go away and be unreachable. But that totally depends on having a whole lot of people who are mirroring all the different data all the time.
Right.
In the scenario where you have something newer or it did wind up getting deleted or hard to find, that's where all of these different tools have very different solutions to that problem. And that is, the question there is this idea of mutable naming is what people typically refer to it as, that sort of space of that problem. And they all approach it really differently. IPFS is one system, has its own set of multiple approaches to that. DAT is another really popular system, which has its own approach to it. Secure Scuttlebutt and many of these other systems all have different answers to that question, but they all do have some form of answers. They may work more or less well, but yeah.
Okay, thanks.
Yep.
And that is a really interesting point on the DWeb, is that you can't, like, it's not simple to delete things. And that's its own kind of problem. That's not so much a problem in the archival space, but it is in the social space.
Well, I would argue that because at least in Earth and environmental sciences, we're definitely moving towards not downloading data, and that you move your processing to the data. And there's, at most 2 or 3 copies of at least the whole data set. Because the scale is such that it's not, we're moving away from a download data world. We're to, but yeah, anyway.
Yeah. I think this would end up moving things in the other direction if it catches hold, which is its own, that's its own challenge, which I actually don't have covered in this presentation, which is like, what do you do with really large data sets? How do you do lots of copies?
And just to add slightly to that, if you're interested in that set of questions, another sort of sidecar thing that is attached to this space of distributed web is the idea of distributed computing.
Right.
So there's a project called Computes that got bought up by somebody else, and I'm not sure exactly how active it is in the original form, but tried to take those ideas of how do you move the computation to the data and support it in a more distributed space where the data might be all over the place. You don't have 1, 2, or 3 places that are storing the data. There might be many. And how do you manage a situation where you want to move your compute near the data, but that might be 50 different places, or 5,000 different places, or 5 million different places.
Well, what was the name of that organization?
Computes.
One more time.
Computes, like compute with an
I
S.
get it. Okay, right. All right. Thanks.
Rob, do you want to throw that in chat? I want to make sure we actually get to the end of the presentation so there's space to chat. And I'm realizing I knew ahead of time this would be a longer presentation than we normally have in Spark. Usually we try to have like 10, 15 minutes and then have the rest for discussion. But this one is much more a presentation. So the other piece that we're going to look at here is key-based addressing, which we already talked about a little bit as a digital signature. And in order to understand a digital signature, you have to know the cryptographic concept of a key pair, which is, this exists for lots of stuff separate from the distributed web, but we're using this here. So the concept of a key pair is that there are 2 pairs that are linked with one another, and what they look like in practice is another one of those super long alphanumeric strings. And the idea is that if you have one that is fed into the algorithm that does the scrambling, the other one is the only key that can be used to unscramble it again, and vice versa. And so then there's this concept of asymmetric key pairing, where one of those keys is held only by you, and you keep it private. You never ever share it with anyone at all. And then there is a public key that you can make public to the internet at large. And the reason you would do that is if you had data that you scrambled with your private key, anyone could access that data, but know that it came from you because it could be unscrambled only by that second key. the way we do this in the distributed web space, it's the signature is the part that is scrambled, not the content. But that's sort of a technical distinction. The important part is that it is significantly more effective than a handwritten signature for saying this came from me. So this obviously looks like that previous slide. So once again, we've got this concept of a protocol identifying the grammar. And then here, this very long string, instead of saying what I'm looking for, it says where I'm looking for the thing, or not where, but what thing that I'm looking for. And the content here is not part of the address, and therefore it is updatable. But it can only be updated by whoever holds that private key. And this string here, this is the public key that goes with the private key. Is that making sense? Probably, okay. So if you have key-based addressing, you can know who made the data, even if you don't know where exactly the data came from. So it can still come from this like very distributed internet full of strangers. There's different challenges here. Because the data is not static, you can't know exactly that it was never changed. You can't know what the changes looked like over time. There's usually a concept of there's frequently a concept of history involved in it, but you can't guarantee that the history that is published is accurate. And once again, you still need it to be kept somewhere online. So if you have content addressing, you can trust the content. If you have key-based addressing, you can trust the source, which could potentially mean that if you had a key-based address that had a list of fingerprints that mapped data sets to the correct fingerprint to download the content from, you could combine these two technologies. And if you had that working, what you would now need is for there to be lots and lots of people, and specifically computers more than people, who have all these copies and are online and using these protocols. All of this stuff is very much in development. We've already gone over this slightly, but so coming back to this concept that the internet is fragile, we now have a whole set of different problems than the one we currently have. We can be more certain, so like there's no concept of a sketchy URL in the same way. You can prove what's there and you can prove who put it there more accurately, partly by virtue of this new internet being developed now rather than many, many years ago. There's more cryptographic concepts kind of built in at the base level, which means that in general, it's a safer thing. It's a safer internet. And this has capacity for peer-to-peer. On the other hand, it has its own problems like any technology will have. And part of it is around the network effect of making sure that the data is online, but part of it is also around the usability of it. It's not necessarily more complicated than the existing internet, but it will be a new paradigm that people will have to understand differently. So there's a whole set of education and expectations that would need to happen. And then one of the things that I like to think about in this space is attention to ethics, values, and justice, which is something that I think we should be bringing forward at the space where we're designing a whole new internet, which I can talk about slightly more in a sec. So who's building the new internet? Well, lots of different folks in lots of different ways, which is to say they're not all compatible with each other. And this is one of the challenges. This slide shows some of the major players in this space. Over on the left side, we have kind of the social stuff. In the center here, we have kind of the data protocols, and these are particularly ones that I'm more familiar with. But IPFS is using content-based addressing as the key, as their key technology, and DAT is using key-based addressing as their core version of addressing. to greatly oversimplify that. And they're being built by different communities. Like DAT is backed by Code for Science and Society, a nonprofit. IPFS is built by Protocol Labs, who also builds Filecoin, and they are a venture-backed company. And then over on this right side, these are things that I'm significantly less familiar with, but are versions of the distributed web or distributed web concepts in the archival space. A lot of this technology is pretty new. One of the reasons that Dana is joining us actually at EDGI is I've asked her to kind of help explore what it feels like to try to put data on some of these various services. And this is a project that I attacked briefly and realized I didn't have the capacity to work on myself. Just kind of writing up what it feels like to do this stuff. But in the short time that I did do it, I learned that it was not easy at all or intuitive. So that's something that we're working on. And by we, I mean, one of the things that EDGI, through the Data Together group, is doing is trying to be in touch with a lot of the developers of these technologies and kind of give that feedback, and especially bridge the use cases from the archival space so that there's something that they're aware of, basically to be the noisy complainer that gets paid attention to as they build. There's a lack of compatibility, as mentioned. So if you put something on DAT, that doesn't mean that you can get it on IPFS. So those are separate internets, though there have been some pathways for making things cross-compatible. A lot of projects are just a few people. Secure Scuttlebutt, this one over here, is mostly, I don't think there's anyone who gets paid to work on it, or if they are, it's like through a Patreon or something. So some of them are just a few unpaid open source folks. The other folks have profit motives, which were part of the issue in the current internet, where Facebook monetizes your data. So there's some challenges there. Actually, as of this morning, Matrix just got funded $8 million, I think. And Reddit's blowing up with, so how are they gonna pay that back on their open source, non-advertising? Anyway, that's gonna be interesting to watch. And then we have the usual issues that we have in the tech space, which is justice and equity issues that generally don't get paid as much attention to, partly because if you're a startup and you're trying to survive, it's just not what you're worrying about right now. Secondly, because if you are in the tech space, the tech sector in general has issues of equal representation. And so that means that a lot of the folks working on this stuff don't necessarily have any exposure to various issues of privacy. And this is something that I've kind of run into by running in these circles, is just watching really naive conversations where like privacy doesn't come up as a concern. Or the concept of wanting to delete something on the decentralized web is maybe not prioritized. So what's EDGI doing? As mentioned, we're testing some of this stuff. So Dana's work is part of this. Another part of this is our member Brendan, based on EDGI's challenges with uploading, with archiving data sets, he actually founded a company called Query, which uses IPFS to hold data sets. And so we have a node that he's hosting where we are a peer on the web, which is kind of a way to feel out what that's like. We have a reading group that we host that brings together a bunch of the people working on this, people from DAT, from Protocol Labs, specifically from the sub-project of Filecoin, which is a way to incentivize storage on the decentralized web. And what we do is we come together every month or so and have these conversations that you wouldn't necessarily get, to try to bring that new perspective in. That you don't have space for as a startup or as just an open source developer trying to get issues closed. So we talk about justice and civics and stewardship. and other subjects in this space. And that's been honestly really productive in terms of just making sure that this is forefront in people's minds as they're deciding what to work on next. We've been trying to, as mentioned, be kind of that bridge between the technologists and the archival use space to make sure that that's kind of a first customer. And this is very specifically Dana's project of testing archival use cases and giving feedback. So I apologize for how long this presentation was as compared to the time we have in our meeting, but I'm curious to hear what's interesting for you folks.
So I think if people have questions, either raise your hand or pop them in chat. Mark already asked whether there's sort of been any thinking around right to be forgotten and requirements imposed by things like GDPR, which I can answer a little bit about, but I don't know if you have bigger picture things to say about that, Kelsey.
I don't have particular expertise on it. It's something that I was really curious about at some point and asked about, but I don't think I got a good answer. It's something that's come up in Data Together discussions.
I would say there are a few people thinking about it, but it also is a really interesting question because as Kelsey noted, right, like this is a space where there's a certain level of homogeneity and a certain level of not prioritizing certain kinds of problems based on the sort of people who are involved. And so this comes up occasionally, but very often in many of these communities, it doesn't get a lot of weight. And it's often viewed as somewhat antithetical to the way people want the tools to work. So there are a few people thinking about it, not a whole lot. One of the technologies in the space is thinking about particular ways of designing those cryptographic hashes or fingerprints, such that you can make certain kinds of changes to the content that would allow you to sort of like wipe out a name or something and not change the hash.
That's like, tombstoning, right?
That's a slightly different thing. Yeah, that's a way of like if you're linking together sort of changes over time to describe a history of something. Tombstone is a way of saying this thing that previously existed in this set of stuff is gone now. So from these changes forward, think about that as gone, and allows you to set some kind of placeholder for that information if you were to remove the other things if you were to scrub them from the history. So that's more of a that doesn't fit into the provability part of the question, but it fits into the, like, if you wanted to add provability to a system where you used a tombstone to replace something that you deleted, you'd need something like this idea of what's called a chameleon hash, which is this type of hash that you can change in certain way. You can change the content in certain ways without changing the hash. But that obviously runs pretty headfirst into a lot of the ideas about provability, because now you're saying like, well, it doesn't exactly refer to the thing that it used to. And what are the implications of that? And is that okay? So there's a lot of sort of entangled argument in this space about just that very idea. And part of that is it's better handled by systems that prioritize that key-based addressing, because it doesn't prioritize as much provability as the content as it prioritizes who said it, right? So if you can legally force the person who said something to change the history, they have the freedom to do that in a system that is more primarily key addressed. But another aspect of this is it hits sort of headfirst into if your system is formalized around this idea that once I've transmitted information to somebody else, they now physically have it, and it's up to them to decide what they do with it. And the system is sort of formalized around that idea and allowing you to get information from all the people who ever had it. Like, that's a tough question. Like, what does it mean in that kind of world where everything is structured around that idea? to be able to say that some piece of data has to be removed. And a lot of that is also about what kind of institutional systems can you build, and encourage people to subscribe to and be a part of. So that is a very open space.
There's a lot of similar challenges around. I know Scuttlebutt had someone coming in who did an accessibility audit, like to make sure that it was, you know, screen readable and such. But it turns out there's 2 developers who are unpaid building the client that got audited, and they don't, like, the accessibility stuff is like, it's not important, but it's not exciting for them to work on in their spare time. And so that's not currently the thing that they're doing, even though now there's a bunch of problems that have been identified by somebody who put in some good work. And that's a really common problem in the open source space, is like, well, whose problem is it to solve that? And no one's incentivized to do it.
Yeah, that's the stuff I'm interested in.
So technically this is the end of our Spark meeting. I didn't leave as much space as I would have liked for conversation. Would it be helpful to have another 15 minutes tacked on to the end, or are you all happy to just sort of quietly digest? All right, we can wrap it up there. I did want to call your attention to the last slide that I have here, which is which has links. You should go look at it in your personal digital copy of it. But we have a discussion coming up in November that the readings are currently posted for, which if you wanted to join our sort of values conversation with developers, this one talks about what is the concept of decentralization from sort of an academic and community standpoint. These middle 2 bullet points are ways to personally interact with the decentralized web in ways that do not require you to be at all versed in coding, I would say. So if you want to kind of poke around and see what it looks like. And then finally, if you want to get more involved, you should reach out to me. That's all.
Hey, Kelsey.
What's up?
So I'm just browsing the sort of the agenda and readings for the topics, and last month you had Hail Maintainers. The maintainers had a conference just earlier this week, Monday through Wednesday. It was very interesting. But that would be a space, I think, that would be good. And there's a monthly group that has discussions that's getting spun up called the Information Maintainers. But they're very much more concerned with these issues, these social and institutional issues of how to make the social values aspect of building a distributed web. They haven't been talking so much about a distributed web, but I think it's a great conversation to bring to that group. So just a thought.
Thanks. All right, thanks everybody. Appreciate you spending your part of your day with me. Any final urgent closing thoughts, or are we good to go? All right, I'll see y'all around.